Professor Tsige and myself and our students in 2019 built a food energy water nexus system on campus that turns wastewater and solid waste into recycled water and energy for irrigation. And teaching the complex interaction between water, energy, and food system is still a challenge. So this lecture presents a virtual reality-based water, energy, food nexus visualization and simulation tool for teaching engineering students. He calls it VRWEF, and it's a powerful immersive tool that places students at the center of an alternative virtual world that makes it easy for you to experiment and learn complex food, energy, water engineering concepts effectively, and then understand the consequences of different development paths. The Food Energy Water Nexus system that we're developing at Florida Gulf Coast University and here at USF is finding its way onto the map in speculative fiction and planning. The idea of using circular economy food and toilet waste-based biodigesters as the basis for aeroponics and hydroponic systems has even been featured as a solution to the zombie apocalypse, as I mentioned, in the popular Netflix sci-fi Z Nation and in The Walking Dead. So it is increasingly on the radar for the public. In Chapter 9 of Tankersley's book, called Reimagining Sustainability, Gabby in Paradise, which gives specifics about the technologies that we need to go about reimagining our tomorrows, making sure your future doesn't suck. His character, Gabby, a 13-year-old Latina girl who's living on the Florida coast sometime mid-century and has seen the worst of climate change, visits her friend Dan, who is helping her city planner aunt, Tia Maria, build, quote, another one of her biodigesters that she describes as kind of cool, though, making gas from food scraps and poop. Dan tells Gabby, as your aunt likes to say, you carry enough energy in your gut to power the entire planet. The biodigesters Dan was helping to build, says Tankersley in the narrative, were the perfect low-tech solution to getting rid of all sorts of organic waste. They were just waste composters designed to trap the gas that the decaying organic matter gave off. The gas could be used for cooking or heating, and it was cleaner and less dangerous than any commercial natural gas. Just one of the many renewable energy sources that powered the village where all of the roofs were covered in solar shingles and that didn't get destroyed every time there was a storm. Now, because of the presence of the biodigesters, the hypothetical village described in Tankersley's book has an aqua farm and aeroponics greenhouse that provides, quote, food for the residents and a source of income, and instead of the traditional lawns growing non-native grasses, the village was filled with ground covers that naturally flourished in a salty coastal environment, so that, as a result, there was no need for fertilizers that used to run off into the bay and cause deadly algae blooms. That's Tankersley, page 129 to 131. Now, when students read this text in the USF Envisioning Sustainability course, they often ask, well, where is this wonderful place, this utopia, this village? How can we visit it? Does it exist on any real map? How do we make it a regular feature of our current communities? So what is needed urgently is to start mapping food, energy, water nexus technologies into real-world, not fictional landscapes, to put them on the map both virtually, so stakeholders can work through possible scenarios before committing time and money, resources, and land, and then in actual, tangible form. Now, we know this is always done. Professionals in planning and architecture and engineering have long worked with geographic information systems to enable spatial analysis for decision-making that's tied to place, so that the real-world locational data can be displayed in meaningful ways and plans can be made for real-world deployment. But as Yale professor James C. Scott famously pointed out in his book, Seeing Like a State, How Certain Schemes to Improve the Human Condition Have Failed, which I often quote, the map is not the territory, so it's critical to add relevant dimensions and data layers to ensure more accurate representation of the landscape, including cultural, social, economic, and political variables, to say nothing of complex ecological parameters. For this, very sophisticated modeling software is needed, says Scott, 1998. ArcView GIS has been considered the standard for decades. Each new release improves on the last by building the data visualization functionality, such as the 3D capabilities found in ArcGlobe, ArcScene, and CityEngine. The company's website extols, quote, if a picture is worth 1,000 words, a relevant map is worth 1,000 pictures. Use 2D maps and 3D scenes created on your desktop to visualize data in novel ways and discover non-obvious relationships, inefficiencies, trends, and opportunities. That's ArcView 2019. However, the expensive pricing structure students must contend with after they graduate has been a deterrent for many who would otherwise invest more time in mastering its nuances. Students who don't find employment in companies and institutions that have site licenses for these powerful software tools often find themselves discouragingly trapped across the digital divide. And ironically, these are the students whose communities and landscapes of interest often need the most help in redesign and solution seeking to stave off the worst effects of climate and landscape changes and habitat loss and environmental injustice. Now, the open source variant QGIS now has much of the same functionality and enables students to do their mapping in a platform that will remain zero cost for their lifetime and will continue to improve over time. But of course, it lacks the support and customer service of the commercial software. None of these mapping tools currently allow for a truly immersive experience, however. While the gaming world is already making more emotive, impactful simulations of green futures, playable to everyone through titles for the PC, Xbox, and PlayStation, such as the City Skylines Green Cities I talked about in the last lecture, that enable players to create a sustainable future, often by playing as the mayor or city planner, with all the food, energy, water, and waste nexus parameters, ecological and economic, budgetary, including trade-offs and political conflict. Players can implement everything from urban wind and solar farms and geothermal heat pumps to EV parking, green roofs, and farmers' cooperatives, and have a nice, ever-expanding menu of green technology choices. The limitations of these hyper-realistic and super exciting games, however, is, as I mentioned, that the green neighborhoods are never located in any real region of interest to students and remain neverland abstractions that at best encourage inquiry into the possible technologies and cost-benefit decisions that must be made for proper implementation, but that rarely prove useful in improving real environments in the real world. See, education, particularly engineering education today, that wants to remain relevant needs to incorporate the best of GIS programs and MMORPGs, massively multiplayer online role-playing games, and do so in a way that is free or inexpensive and that is accessible and will remain accessible for all students for the rest of their careers and lifetimes. Actually, the software to create immersive real map-based scenarios that are local and unique is already here. With the improvements to cost-free browser-based services like Google Earth and Google Maps and OpenStreetMap, OSM, and the available of open-source 3D modeling and gaming software like Blender 3D with its new Blender GIS plugin that enables use of web geodata from Google Map, OSM, and DEM SRTM data, that's Digital Elevation Map, JPL, NASA Shuttle Radar Topography Mission data, and free-to-use world-building software such as Unreal Engine, Unity 3D, and Roblox Studio, students are beginning to see that you can do better than 1,000 pictures by mastering these cost-free tools to create your own truly interactive, multiplayer immersive simulations of your own local topographies and communities so that you can play through scenarios relevant to you and your futures in real time. Scenarios that include the cultural, psychological, and emotive content that open-world gaming with real-time multiplayer functionality brings to the table, and make better system thinking, nexus thinking decisions based on the impressions of a multitude of stakeholders. Tankersley predicts that once, quote, almost anyone could afford access to the great data stream, the digital divide that we have been building will start to crumble as cheap data helps jumpstart the micro-entrepreneur movement and access to precise data focused on a local population, quote, becomes a powerful tool for discovering innovative solutions to problems that had once seemed intractable or at the very least unprofitable, end quote. Most importantly, he maintains, they give those communities, quote, the power to imagine their own futures rather than forcing them to accept solutions that lack connection to community traditions and values and left too many people feeling like their only choice was someone else's future or their own crumbling past, end quote, Tankersley, page 90. He says, quote, the great disruption of the digital age was to make us all realize that every future is local and unique. Empowered by the tools that make bottom-up change possible and fueled by the millennial generation's newfound embrace of community and tradition, local solutions spread. To those who are creating community futures, tomorrow seems less like a giant leap into the unknown. Tankersley Ibid. Now, Sige says, research in virtual reality in education is a relatively young field, but in recent years it has shown considerable growth. Recent examples of the application of VR in undergraduate education have focused on the potential of interactive and immersive displays in order to make the interface for the learning experience easier and more natural to students.